Good morning, everybody, and welcome back to Next Door NetAdmin. Today, I'm working on a little bit of a project. A client has asked us for a system with some very particular requirements, and I'm going through and figuring out what the best solution is and validating that it will work as I expect it to. So there's going to be a little bit of back and forth in this one. I'm basically just pulling back the curtain on how I'm going to sort this out, and you all get to watch me. And I mean, maybe if you have some experience in this, you can just sit there yelling at the screen that I'm doing it all wrong. I don't know, but hopefully by the end of it, I've got a system that works. So starting out with what are the client's requirements specifically? Well, these are their needs. It needs to be Linux based. They say that they have more experience working with Red Hat, but they do not require Red Hat. A Debian based system is okay, as is anything else. It is going to be air gapped. It is not going to connect to network. It is never going to connect to network. They want a resilient slash redundant file system. They were thinking like RAID 1 or RAID 5. And I spoke up and said, well, how about something similar to RAID 1, but like we could also do like a three-way mirror. And they went, oh, you know what? That would actually be amazing. If we could have, because their main concern with RAID 1 is that it only has one disk fault tolerance. So does RAID 5. But regardless of that, they're like, you know what? If we could have just a three-way mirror, three discs that are all the same, that would be amazing. That would be actually really good. So I'm like, okay, sounds like a great idea. I can do that. We do need full disk encryption. They want, a reliable system. Okay. They want something that doesn't need updates very frequently, if ever. And I'm thinking to myself, if it's air gapped, then that means updates basically never, because otherwise it's not air gapped anymore. But they also want this to be a long term system. So they want this to have a lifetime of something like 10 years. Okay, that is more of a hardware problem in my mind than a software problem. It is going to be air gapped, but if it's air gapped, then you can basically keep it turned off most of the time. And in fact, that is their plan. They're going to keep it turned off most of the time and only turn it on when they need it for very specific tasks. Okay. So those are their requirements. And as I was doing a bunch of research, because spoiler, I've already done a good 6 to 8 hours worth of research on all of this just to get to this point. And I'm kind of walking you through where we are and how I got there. There's a lot of documentation out there that says, oh yeah, you'll have to disable secure boot because these modules aren't signed. But I know how to sign kernel modules with an MOK. I did a video on it using an MOK. I've used this to sign modules for backup systems. I've used this to sign modules for the docking station that I use with my Framework laptop. I know it works. So this is a want on my side, not required in the client's needs, but I know I can make this work with secure boot. So why wouldn't I? It's just another brick in your security firewall. Why would you take it out unnecessarily? So that's a want that I've got, is to have it secure boot enabled. Now, in terms of selecting a file system for this, as far as I can see it, there's two main candidates. One is BTRFS, and I'm just going to put in here candidate solutions. There we go. One being BTRFS. BTRFS is the B tree file system. I've heard people call it ButterFS. I call it BitterFS because, It's not particularly buttery as far as I'm concerned. B-tree file system, Bitterfis, fine. This is the default file system on Fedora, as far as I'm aware, on Fedora desktop. It has a RAID 1 C3 profile. Now, there's a slight difference in concept between a three-way mirror that mimics a RAID 1 but with 3 disks instead of 2 versus the BTRFS RAID 1 C3 profile. This is RAID 1 copies 3. So conceptually, 3 copies of your data, but BTRFS doesn't mirror the entire disk. It does this by mirroring extents, chunks of the disk, typically about a gigabyte in size. And it will make sure that there's 3 copies of this chunk somewhere in your array. They're not guaranteed to be on different disks because this is designed so that you can have disks of different sizes. It'll just make sure that there's 3 copies somewhere. Maybe they'll be on different drives. They may be in different locations on the drives too. And okay, that's interesting, but it's not exactly the same thing as a three-way mirror. You've got 3 copies of your extents, fine. But if they're not guaranteed to be on the same disk, at least one is guaranteed to be on a different disk, because otherwise you could lose one disk and lose everything for a particular extent anyway. But you might lose a disk that had 2 of the copies on it, and now you're down to only 1 copy, even though you've only lost 1 disk. That's not exactly what I was hoping for, but it's a possibility. BTRFS also has a lot more manual work to it, where there's a command to rebalance everything. This is something that I've discussed from a ZFS perspective, but B-tree file system does have a rebalance command, but it has this specifically because rebalancing is how you ensure that this data is actually kept in the locations that work. And so there's a lot more manual maintenance of your file system rather than just keep going and use it under normal circumstances and it will gradually balance itself out. B-tree file system is very big on the manual commands from what I've seen. And if I pop open a browser here for a moment, this is the status page for the BTRFS file system on readthedocs.io. And there's a lot of entries that are okay or mostly okay. But if you keep scrolling down, block group profiles, RAID 1 C3, stability is okay, performance is mostly okay. But there are some parts of the file system, for example, RAID 5 and RAID 6, which are still unstable and should not be used in production. There are also features that are partially compatible and partially not compatible. So there's a lot of in progress. There's a lot of stuff that's still in progress with the file system. It's not necessarily what I consider stable long term. It's probably stable-ish enough to work after a fashion, but is it something that I'm willing to trust for 10 years in a completely offline environment where I may or may not have the ability to log on and troubleshoot it? I may not have the ability to do regular maintenance on it. So those are open questions that I have that I'm not 100% on. I also don't know anything about its secure boot status at all. But I would assume that it can be done. Oh, there was something else that I saw. Let me see if I can pull this up for you. This is the page that I had in mind to show you. This is a discussion forum specifically to Fedora on fedoraproject.org, and it's about Bitterfist RAID 1 for fully self-healing usage. The good news is, if the behavior you want or need is unattended, degraded boot, it's difficult but pretty much a no-go with BTRFS at present. And this was posted August 15th, 2025, this year. So as of this year, degraded boot, if a disk has a problem, BTRFS is just not going to boot. Pretty much, period, end of story. But if your goal is error detection and correction of all metadata and data, yes, that exists today, and it's stable using RAID 1 C3. Okay, so from the perspective of the Fedora project, you can use this, but if it's going to have a failure and still be able to boot from it, it's not really going to work. Certainly not going to work well. In which case, am I going to be able to implement this without spending a month or two on it? I'm not sure. There's also a relatively tight timeline on this project. They're hoping to have something confirmed within 2 weeks. So, all right, I may or may not be able to actually do that. So, another alternative that I've talked about a whole bunch and already mentioned is ZFS. Okay, well, ZFS, it's not a default on any Linux distribution that I'm aware of, but there is an option in Ubuntu that supports it. And Ubuntu, of course, is Debian based. So I know that it's supported there. They actually have an option in the desktop installer to support it and actually install a system to it. All right, fine. And I know that three-way mirroring is supported. So fortunately, the client does not require Red Hat. They're okay with Debian. So I'm thinking that this is where I'm going to go. I could set this up manually, but I happen to know already that the Ubuntu desktop installer supports secure boot and supports setting up an MOK because that's how they support third-party drivers. They create an MOK and enroll that automatically as part of your installation so that you can sign kernel modules like ZFS, which all the documentation says, oh yeah, you'll have to disable secure boot because it's not supported. I don't know why people keep saying that. It's absolute trash. I don't think the desktop installer, I've never run the desktop installer for Ubuntu, or at least I have, but it was a while back, and it was in 2204, not the current 2404. I would bet that it doesn't support three-way mirroring in the installer. But if I can get it to install to a two-way mirror, I can actually manually run a command to add a third disk into a three-way mirror after the installation. And then it'll resilver and I'll be able to, keep going from there. So as long as I can get a system that boots correctly with two disks in a mirror, ZFS, and I know that ZFS has support for full disk encryption, great. And that's actually an option in the desktop installer as well. So there we go. Then I should be able to just add a third disk and I'll be pretty set. Hopefully. This is what I actually need to test and make sure that it works. So let's put this down and take a look at the virtual machine that I've set up to validate this. We've got your basic little bit of memory, little bit of processor, good enough for what we're doing. I've added 3 hard drives. They're all 40 gig drives on this virtual machine, and then a DVD drive for the desktop installer. No network connection because it's air gapped. And that's pretty much it. What I'd like to do as part of this validation is validate that the desktop installer presents the correct options and gets me into a place that I'm expecting it'll get me into. Then I want to validate that I can add the 3rd hard disk as the commands say I should be able to. And then I want to start playing with, okay, if I remove a drive entirely, can I still boot? If the system is degraded, does it turn on and does it actually boot correctly? So when I have, hard drive 0, okay, well, I'm sure it will try and boot from hard drive 0 pretty much all the time. But if I take drive 0 out, does it still boot off of drive 1? Does it still boot off of drive 2? These are the things that I want to validate in my design before I move forward on building the whole thing. So let's get started on that. And one other thing that I will mention just briefly is I keep saying the desktop installers, desktop. What if this is server-based? Well, it is going to be essentially a server. I happen to know that one of the applications the client wants to run is pSQL. So, okay, but if I'm building SQL, don't I want something server-based? Yes and no. Yes, from at least one perspective that I can think of, does it really need a GUI? No, probably not. But again, this is an air-gapped system, which means that somebody needs to be able to log on to it physically at a keyboard with a monitor. There will be no remote access to this system where you can open up SSH and have your browser open at the same time looking at commands and copy pasting them. You might have somebody who does not have experience doing everything from the command line, and they may or may not be able to, look at their phone while they're doing this easily. So for that reason, some people may actually be more comfortable with a graphical environment available to them. And from a practical perspective, the desktop installers for both Fedora and Ubuntu have options that the server installers don't. The server installer for Ubuntu does not include ZFS. It's not because it's somehow less stable. For general use, at least, it's that they haven't decided it's stable enough for most server installations, or it's not frequently used enough to warrant being included in there. They only just added it into the desktop installer as it is for 2404 on the Ubuntu side. Fedora has had BTRFS as default for a while. And they didn't quite get it into desktop and server at the same time. I'm sure it will be an option on a server installer in the relatively near future, but for now, desktop installer is what I've got, so that's what I'm going to install. If they come back and tell me we don't need a GUI environment, then I should be able to just take the GUI environment out after I've installed the system using the desktop installer. Really, I'm looking at the installer as doing the bulk of the configuration work for me, and then I can just touch it up and add a few more things on at the end of it. So let's get started and see how this goes. I'm probably going to jump around a little bit in the editing so that you don't have to watch me fumble through all of this, but let's see where we get to. So after going through the setup process for the installer, language select, key map select, and the fact that I don't have internet, yeah, let's try installing Ubuntu. Interactive makes sense to me. Um, just the essentials sounds good. We don't need office tools, utilities, etc. I honestly don't need a web browser. This is an air-gapped system, but it's part of just the essentials. Okay. Yeah. So let's do third-party software, because that is what's going to trigger the setup for secure boot if I'm right. Watch me be wrong. Okay. So advanced features. There we go. Erase disk, use ZFS with encryption. So this will do ZFS and full disk encryption at the same time. It's labeled experimental because it's new to the installer, but the file system and the feature set very much not experimental. So there we go. Yeah, we'll just put it on SDA for the time being. Even if it installs it in ZFS single disk, I can add multiple disks to it to turn it into a mirror and then a three-way mirror. So even if that's the case, fine. So this is the passphrase to turn on the computer. Okay. So on SDA. Oh, this is ZFS on Lux. Okay. Is it ZFS on Lux? Or is it Lux on ZFS? I don't know. Well, let's find out. This is the whole point of doing a validation of the design, is to test it out and make sure whether it's doing what I want it to do or whether it's doing something else. Lux is a standard way of doing full disk encryption in Linux. It's not ZFS native encryption. So I'm curious as to how this is going to be set up, because it might affect how I'm able to add the disks. If it's Lux first and then ZFS on top of it, then I might need to create additional Lux volumes and then add those ZFS partitions to the mirrors. If it's Lux on ZFS, where ZFS is down here and then Lux is on top of that, then I can just add the disks to ZFS and it'll replicate the encrypted partitions on top of it. So I'm hoping this is Lux on ZFS and not ZFS on Lux, but I don't know. So let's let the installer do its thing and we'll find out. While it's installing, I'm just thinking, the choice of whether it's Lux on ZFS or ZFS on Lux will also affect the ability to boot degraded, because you're going to need a boot partition that is unencrypted so that you can actually load the bootloader and then decrypt the rest of the disk. That's how it always works. If you have ZFS on Lux, then you're going to need to manually replicate that boot partition outside of ZFS. Whereas if it's Lux on ZFS, then adding the disk to the VDEV should replicate all the partitions, including the boot partition, which would make it a little more survivable. So yeah, that's also something that might affect how we go with this. Again, we'll just have to see. You know what? Let's continue testing, because I want to take a look at what this system has done. Let me take a look at what the partitions are. Device ZD0. 36 megabyte DM crypt 0. Okay. There's a lot of loop devices here. But we've got SDA, which is my main disk here. Look at all the loop devices. Goodness me. But we have our boot partition, which is what I would expect. And then we've got additional partitions under that. Okay. So we've got a boot pool, target boot. We've got an R pool with a root file system and then a root data set. I'm going to assume that is. With /target being our new /root, I think, by the look of it. And then a user data set with home and root partitions on it. And then we've got a key store. Yeah, I'm just going to reboot into the new system and take a look at it from there so that I don't have all of these loop devices and everything cluttering. Well, I say that, and yet I'll still have loop devices cluttering everything up. This is Ubuntu. It has a lot of loop devices, generally speaking. But what I will have then is I will have squash fs. Yeah, whatever. I'm not worried about that. That's from the CD file system. But mainly I'll have an actual root file system mounted, and I'll be able to look at the installed systems FS table and everything else to get a better idea of what I'm looking at. Of interest, when I look at this boot menu item in Grub, I can see very clearly that we're inserting a mod for ZFS. Cool. And we should be booting with the root ZFS pool indicated and the initial RAM disk also on the boot volume. But these are the ZFS designators. So we might be doing Lux on ZFS and not ZFS on Lux. So this is encouraging, I would say. So now that that's done again, let's see if I can just restart directly without that silly little squash FS error that threw things off the last time. Ah, this is something that I didn't see before. It was just waiting for enter to restart the system. Okay. So yeah. Aha! Unlock disk key store rpool. Okay. This is crypt setup has opened key store rpool, and then the key store for the root pool has the key to unlock the rest of the system. So as running, this is secure boot enabled. So tick on that. All right. I see how this goes. Okay. So this DM crypt 0 line is the swap partition. I should have seen that first, which means that that's going to be on our third partition, probably. We do fdisk-l to confirm what I've got. Dev mapper key store rpool dev mapper DM crypt 0 is swap. ZD0 is, yeah, so I've got my EFI boot partition. I've got my boot pool in ZFS. Got a swap partition, and then I've got the root file system. Okay. I'm going to do zpool history. Okay. So, all right. So the Z pool was created. Mount point boot. Device was dev disk by ID. Yada, 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 yada. Which looks like it was a raw partition. That's the boot pool. Now, how about the root pool? Aha! Okie dokie then. So this was created on the disk by ID, blah, 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 partition 4. The ZFS, okay, it is using ZFS native encryption on. This is why it's so useful to actually look at an installed system in situ, because I could have done a whole pile of research on this and still not have known what I was looking for. Now I've got questions that I can actually do more research on and ensure that I understand this correctly. But given that I'm reading this correctly, if I'm reading it correctly, then it should be as simple as copying my partition table from one disk to the other to essentially set up the partitions, and then add those partitions. It won't replicate swap, but I don't care if I replicate swap. If I actually look up here at how crypt tab, where did it is? Here it is, crypt tab. Crypt tab is setting this up with a random key. So your swap partition is essentially cleared on every boot, which is a safe way of doing swap. That's totally understandable, but it means that your swap partition is never going to be recovered anyway. So if I have that, I'm not really worried about this partition UUID not being available. If it's not available, it's not available. Too bad, so sad, no swap. I don't care. Okay. So if that's the case, that I just need to copy the partition table over and then work with it from there. Okay. This might require a part 2. Because, yeah, I think I've got a pretty good idea of what I'm looking at now. But I'm going to go do more research. And then I'm going to come back to this. And this video is probably long enough, even edited. So I'm going to let you guys go and do a little bit more research. Then we'll come back and see if I can't get this the rest of the way to the setup that I want, or figure out what I'm doing otherwise. So hopefully this has been an interesting look at what a system administrator might actually go through when designing a new system to meet specifications and then validating that. Hopefully you found that interesting, enlightening, maybe even something to put on in the background. I don't know. But anyway, if you have other ideas on things that you'd like to see me think about or demonstrate or just talk about, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.